the science of photonics includes the generation, emission, transmission, modulation, signal processing, switching, amplification, and detection sensing of light. It covers all technical applications of light over the whole spectrum from ultraviolet over the visible to the near, mid and far infrared. Most applications, however, are in the range of the visible and near-infrared light. The term photonics developed as an outgrowth of the first practical semiconductor light emitters invented in the early 1960s and optical fibers developed in the 1970s. History of photonics. The word photonics is derived from the Greek word photos meaning light. It appeared in the late 1960s to describe a research field whose goal was to use light to perform functions that traditionally fell within the typical domain of electronics, such as telecommunications, information processing, etc. Photonics as a field began with the invention of the laser in 1960. Other developments followed, the laser diode in the 1970s, optical fibers for transmitting information, and the erbium-doped fiber amplifier. These inventions formed the basis for the telecommunications revolution of the late 20th century and provided the infrastructure for the Internet. Though coined earlier, the term photonics came into common use in the 1980s as fiber optic data transmission was adopted by telecommunications network operators. At that time, the term was used widely at Bell Laboratories. Its use was confirmed when the IEEE Lasers and Electro-Optic Society established an archival journal named Photonics Technology Letters at the end of the 1980s. During the period leading up to the dot-com crash circa 2001, photonics as a field focused largely on optical telecommunications. However, photonics covers a huge range of science and technology applications, including laser manufacturing, biological and chemical sensing, medical diagnostics and therapy, display technology, and optical computing. Further growth of photonics is likely if current silicon photonics developments are successful. Relationship to other fields. Classical optics. Photonics is closely related to optics. Classical optics long preceded the discovery that light is quantized, when Albert Einstein famously explained the photoelectric effect in 1905. Optics tools include the refracting lens, the reflecting mirror, and various optical components and instruments developed throughout the 15th to 19th centuries. Key tenets of classical optics, such as Huygens' principle, developed in the 17th century, Maxwell's equations and the wave equations, developed in the 19th, do not depend on quantum properties of light. Modern optics. Photonics is related to quantum optics, optomechanics, electro-optics, optoelectronics and quantum electronics. However, each area has slightly different connotations by scientific and government communities and in the marketplace. Quantum optics often connotes fundamental research, whereas photonics is used to connote applied research and development. The term photonics more specifically connotes the particle properties of light, the potential of creating signal processing device technologies using photons, the practical application of optics, and an analogy to electronics. The term optoelectronics connotes devices or circuits that comprise both electrical and optical functions, that is, a thin-film semiconductor device. The term electro-optics came into earlier use and specifically encompasses nonlinear electrical-optical interactions applied, for example, as bulk crystal modulators such as the Pockels cell, but also includes advanced imaging sensors typically used for surveillance by civilian or government organizations. Emerging fields. Photonics also relates to the emerging science of quantum information, in those cases where it employs photonic methods. Other emerging fields include optoatomics, in which devices integrate both photonic and atomic devices for applications such as precision timekeeping, navigation, and metrology. Polaritonics, which differs from photonics in that the fundamental information carrier is a polariton, which is a mixture of photons and phonons, and operates in the range of frequencies from 300 GHz to approximately 10 THz. Applications. Applications of photonics are ubiquitous. Included are all areas from everyday life to the most advanced science, for example light detection, telecommunications, information processing, lighting, metrology, spectroscopy, holography, medicine, military technology, laser material processing, visual art, biophotonics, agriculture, and robotics. Just as applications of electronics have expanded dramatically since the first transistor was invented in 1948, the unique applications of photonics continue to emerge. Economically important applications for semiconductor photonic devices include optical data recording, fiber optic telecommunications, laser printing, displays, and optical pumping of high-power lasers. The potential applications of photonics are virtually unlimited and include chemical synthesis, medical diagnostics, on-chip data communication, laser defense, and fusion energy, to name several interesting additional examples. Consumer equipment, barcode scanner, printer, CDBL array devices, remote control devices, telecommunications, optical fiber communications, optical down converter to microwave, medicine, correction of poor eyesight, laser surgery, surgical endoscopy, tattoo removal, industrial manufacturing, the use of lasers for welding, drilling, cutting, and various methods of surface modification, construction, laser leveling, laser range finding, smart structures, aviation, photonic gyroscopes lacking mobile parts, military, IR sensors, command and control, navigation, search and rescue, mine laying and detection, entertainment, laser shows, beam effects, holographic art, information processing, metrology, time and frequency measurements, range finding, photonic computing, clock distribution and communication between computers, printed circuit boards, or within optoelectronic integrated circuits. In the future, quantum computing, overview of photonics research. The science of photonics includes investigation of the emission, transmission, amplification, detection, and modulation of light. Light sources used in photonics are usually far more sophisticated than light bulbs. Photonics commonly uses semiconductor light sources like light-emitting diodes, superluminescent diodes, and lasers. Other light sources include single-photon sources, fluorescent lamps, cathode ray tubes, and plasma screens. Note that while CRTs, plasma screens, and organic light-emitting diode displays generate their own light, liquid crystal displays like TFT screens require a backlight of either cold cathode fluorescent lamps or, more often today, LEDs. Characteristic for research on semiconductor light sources is the frequent use of 3V semiconductors instead of the classical semiconductors like silicon and germanium. This is due to the special properties of 3V semiconductors that allow for the implementation of light-emitting devices. Examples for material systems used are gallium arsenide and aluminium gallium arsenide or other compound semiconductors. They are also used in conjunction with silicon to produce hybrid silicon lasers. Transmission media, light can be transmitted through any transparent medium. Glass fiber or plastic optical fiber can be used to guide the light along a desired path. In optical communications, optical fibers allow for transmission distances of more than 100 km without amplification depending on the bit rate and modulation format used for transmission. A very advanced research topic within photonics is the investigation and fabrication of special structures and materials with engineered optical properties. These include photonic crystals, photonic crystal fibers and metamaterials. Amplifiers. Optical amplifiers are used to amplify an optical signal. Optical amplifiers used in optical communications are erbium-doped fiber amplifiers, semiconductor optical amplifiers, Raman amplifiers and optical parametric amplifiers. A very advanced research topic on optical amplifiers is the research on quantum dot semiconductor optical amplifiers. Detection. Photodetectors detect light. Photodetectors range from very fast photodiodes for communications applications over medium-speed charge-coupled devices for digital cameras to very slow solar cells that are used for energy harvesting from sunlight. There are also many other photodetectors based on thermal, chemical, quantum, photoelectric and other effects. Modulation. Modulation of a light source is used to encode information on a light source. modulation can be achieved by the light source directly. One of the simplest examples is to use a flashlight to send Morse code. Another method is to take the light from a light source and modulate it in an external optical modulator. An additional topic covered by modulation research is the modulation format. On-off keying has been the commonly used modulation format in optical communications. In the last years, more advanced modulation formats like phase shift keying or even orthogonal frequency division multiplexing have been investigated to counteract effects like dispersion that degrade the quality of the transmitted signal. Photonic systems. Photonics also includes research on photonic systems. This term is often used for optical communication systems. This area of research focuses on the implementation of photonic systems like high-speed photonic networks. This also includes research on optical regenerators, which improve optical signal quality. Photonic integrated circuits. Photonic integrated circuits are optically active integrated semiconductor photonic devices which consist of at least two different functional blocks. These devices are responsible for commercial successes of optical communications and the ability to increase the available bandwidth without significant cost increases to the end user, through improved performance and cost reduction that they provide. The most widely deployed PICs are based on indium phosphide material system. Silicon photonics is an active area of research. See also, related topics. Industry consortia, European Photonics Industry Consortium, Photonics 21, a voluntary association of industrial enterprises and other stakeholders in the field of photonics in Europe. References: What is photonics? C. Mouse promises bright future. BBC News January 3, 2001. Retrieved May 5, 2013. External links: International Optical Societies, EOS, European Optical Society, EPIC, the European Photonics Industry Consortium, OSA, the Optical Society, IEEE Photonics Society, SPIE, the International Society for Optical Engineering, National Societies and Associations, OPTEC, National Science Foundation's National Centre for Optics and Photonics Education, Photonics Cluster Netherlands, the Internet portal of the Dutch Photonics Society, periodicals. Research networks, EuroFOS, Europe's research network on photonic systems, EPICSnet, European Network of Excellence on Photonic Integrated Components and Circuits, Bonn, Building the Future Optical Network in Europe. Further reading, Optics and Photonics, Physics Enhancing Our Lives by Institute of Physics Publications.